Okay, everybody, we are going to start doing the work that we've been doing, but just going backwards. We're going to give you a graph of the trig function, and you are going to then write the equation. We will tell you which function to use, so in this case we will be asking you to write the equation using sine. There'll be several correct answers, so you may come up with something different. I'm just going to show you the basic process of what we go through. You definitely have to use sine. What we're looking for is to find the A, B, C, and D. I'm looking at this graph here, and I want to find like a full sine curve. So I see a full sine curve happening here. Remember, sine is middle, high, middle, low, middle. From here, I can see that I do have a new center happening here. That means that my D value has been moved down 1. The A value, which is the distance from the middle to the high and low points, in this case would be 2. I'm looking at the period. B represents the period in our equation here. So I'm starting at negative pi over 2, ending at 3 pi over 2. So the period is still 2 pi. To find your B value, you take the normal period for your trig function, for sine is 2 pi, divided by the current, so we get a B value of 1. If you have a B value of 1 and you see a phase shift, the phase shift will be what you see on the graph. So in this case, it got shifted negative pi over 2. So now we have all of our values. A is 2, B is 1, C negative pi over 2, D is negative 1. We're now ready to write our trig equation. So it's going to be 2 sine, the B value is 1, just x. Remember, it's minus C, so if we minus a negative, we get a plus pi over 2, and then the vertical shift. Okay, moving on to problem number 2. We're looking to use secant. In order to get that, I first want to get my cosine curve in there. Remember, secant is the reciprocal to cosine. So first I'm going to get a couple of my asymptotes onto my graph. I'm just going to put a couple in there. I'm going to get the wave going to see what I need. So I'm looking to find that cosine graph. So this is coming off of a wave that's looking like this. So the cosine I'm going to be using is going to happen between here and here. So while I'll be writing a secant equation, I am going to be using the A, B, C, and D values off that cosine curve. So I'm looking here. The center value is still on the x-axis, so I know my D is 0. It does have an amplitude of 1, 2, 3 off the center, off the middle line. The period is happening from negative pi over 4 to 3 pi over 4. So the period for this particular curve is pi. Now remember, your B value is the normal period divided by the current one which we have. So in this case, our B value is going to be 2. To find the C value, you have to look to see if we have a phase shift, and we do. Normally, the cosine starts on the y-axis, but now it's starting at negative pi over 4. However, since we've had a period change, we're going to have to do a little calculating to figure out what that C value actually is. Inside the parentheses, it normally says bx minus c is equal to 0. We will fill in the B value of 2, which we found. So you always have to find that B value first. The x is going to be what the phase shift is that I'm looking at. So in this case, it is negative pi over 4 minus c equals to 0. Add the c to the other side, and we're going to wind up with minus pi over 2. Now we have all 4 values. So we're going to say y is equal to 3 times the secant of 2x. Since the c is minus, it's going to show as a plus inside the parentheses. And then, of course, we do not have a vertical shift up or down, so there's no need to write that. All right, let's move on to problem 3. We're moving down a little bit. I like to use this one using cotangent. So first I'm looking for those asymptotes because that's going to help me decide what my current period is. So here and here. So normally the period would be pi, but it's going from negative pi to pi. So I do have a current period of 2 pi. So remember, your b value is going to be what your normal period is for cotangent would be pi, divided by what we're currently looking at. So I got a b value of 1/2. Our a value would be considered the stretch. So here's our new center point. It's going up 1 and 1. So I know I have an a value equal to 1. I do have a phase shift. Normally cotangent has a asymptote sitting at right on the y-axis, and it has been shifted to negative pi. Since I have a separate new b value, we are going to have to do that calculation. So bx minus c is equal to 0. I know my b is 1/2. The x is the phase shift that we're looking at, which is negative pi minus c equals 0. Add the c to the other side. Do the multiplication here, you get negative pi over 2. I also see that normally our cotangent curve would start on the x-axis. We do have a new middle line, so the d value moved it up 2. So what we're going to have is our equation here is going to be y equals the cotangent 1/2 x, again it's the opposite sign for the c, plus pi over 2 plus 2. Okay, moving on to example number 4. We're looking at writing a tangent curve. So I'm kind of looking for my asymptotes. I got one sitting here, and I have another one sitting right here. So I'm looking at this here. Normally for tangent we start on the y-axis, and it normally would spread out to negative pi over 2 and positive pi over 2. So this one's between negative pi over 4 and positive pi over 4, giving me a period of pi over 2. So again, to get that b value, you take your normal period divided by what you're looking at. That will get us a b value of 2. I'm looking to see what kind of stretch my tangent curve has. It is heading up, it is increasing, so I do know it's going to be positive, and I can see that it has a stretch again of just 1 unit up and 1 unit down. So again, we're looking at an a of 1. I'm trying to see if I have a phase shift. Again, normally tangent starts on the y-axis, it's on the y-axis, so we have no phase shift. But it did move down 1 unit. That center point did move down, so we have a d equal to negative 1, giving us an equation of y is equal to the tangent of 2x minus 1. No parentheses are needed here. If you were to put them in, it would just be around this piece here. Remember, the vertical shift needs to be on the outside. All right, folks, flip your papers over. And let's go to the other side. Right, I'm looking to write a cosine curve, so I need to find a full cosine wave happening. There's one starting here and ending here. Remember that cosine goes high, middle, low, middle, high. All right, so it's starting at negative pi over 4. It's ending at pi over 4, so that's 8 pi. That's a big stretch. So our b is going to be our normal period for cosine, which is 2 pi, divided by the current. So we're going to get a b value of 1/4. I do see a new middle line happening here. So our A value is the distance between the middle line and the top and the bottom. So we have an A value of 1. Normally cosine would start on the y-axis. I do see a phase shift. Knowing that I have a period change means I have to do the calculation. Bx minus c is equal to 0. Our b in this case is 1/4. We always substitute in for the x the phase shift that we see. So I'm looking this as negative pi, 4 pi, excuse me, negative 4 pi minus c equals 0. The 4's will cancel out, leaving us with minus pi is equal to c. And again, we did have a vertical shift of minus 1. So our equation here is going to be y is equal to the cosine of 1/4 x. Since this is minus pi in our equation, we take the opposite side of pi, and then the vertical shift of negative 1. Okay, using cosecant graph here, I first need to get in the curve that I'm looking for. I like to put in my asymptotes. I keep thinking to myself, the reciprocal of cosecant is sine, so let me see where I can find myself a sine curve. So it's happening here to here. Okay, so there's the sine curve that I'm looking at. That's where I'm going to grab the A, B, C, and D off of. If I'm looking at the A, the amplitude is equal to 1. It's happening from minus pi to pi. It does have a period of 2 pi. So remember, it's the current period, the normal one over the current. So we do have a B value of 1. Once you have a B value of 1 and you see a phase shift, which we have, normally sine would start on the y-axis, now starting at negative pi. The phase shift you see is what the C value is if the B value is 1. So in this case, that's just going to be negative pi. And we do have a shift off the x-axis. It moved down 2 units, so our D value is negative 2. Now that we have all 4 of those letters here, we can write our equation. Y is equal to the cosecant of x plus pi, again the opposite sign, minus 2. Sometimes, as we move on to examples 7 through 10, you may be not given a graph, but just the various information that you need. It tells me that the amplitude is 2, and I want to write a sine function. So y is going to equal 2 sine. It tells me I have a period of 3 pi. To get the B value, it's the current, or the normal period over the current. Pi's will cancel, so we're going to get a B value of 2/3 x. It does not mention a phase shift, so we can close up the parentheses or not have them at all. Either is fine. Then the vertical shift of minus 3. Moving on to number 8, we're looking to write this as a secant. This really shouldn't have had the word amplitude. It should be stretch, because secants do not have an amplitude. They continue on and on forever. So I'm looking here. We're going to go y is equal 2 times the secant. So if I think of secant, it is the reciprocal of cosine. The normal period for cosine is 2 pi. The current is 2 pi. So I know my B value is 1. 1 will not need to be written into the graph itself, so it's just going to be x. Again, not mentioning any kind of phase shift left or right, so we can move on to the vertical shift of just plus 3. All right, let's scoot our papers down just a little bit more. We'll work on 9 and 10. I'll bring that up a little. No, that's all I can go. Okay, so I'm looking here. I'm looking to write a cosine function. I know I have an amplitude of negative 3. I want it to be a cosine. I do see that I had a period change. So remember, the period is the normal over the current. So that's going to get us a B value of 8. Big number. So that's going to be 8 x, it does have a phase shift, so I want to put those parentheses up. I'm going to need to solve a little bit for the phase shift. So we do know that it's going to be bx minus c equals 0. So 8x minus the phase shift of, or times the phase shift of negative pi over 4 minus c will equal 0. C's over here. We're going to wind up with the c value of 2 pi. Again, it would be the opposite inside the parentheses here. And lastly, our vertical shift of up 2. Alright, last problem here. Let's change colors. I don't really like that yellow. I'm looking for a tangent function. I got a stretch of 3. Tells me the period is 3 pi. So b is going to be the normal period for tangent, which is pi, divided by the current. So I get a b value of 1/3. It is showing a phase shift. So bx minus c is equal to 0. I know the b is 1/3. The phase shift is minus pi minus c equals 0. Scooting that c to the other side, we get minus pi over 3. Of course, in our equation, it is the opposite sign, and the last piece would be the vertical shift. Alright guys, I hope you enjoyed this lesson here, or at least that you find it helpful. I'll be trying to record as many as I can for you. Bye.